All right, let's talk about percent composition. So as it says, the percent composition of a compound is the mass percent of each element in the compound. So if we have a compound that it's made up of multiple different elements, we can figure out what percentage of the mass of that compound each element makes up. And so as you see there, there's the equation there. So the mass percent of said compound, all you have to do is take the number of atoms of a specific element, multiply it by its molar mass, and then you divide it by the molar mass of the entire compound, and then multiply that by 100 to get your percent. And so I'm going to show you an example here. So here we just have sodium chloride. So calculate the percent composition for each of those elements there. So it's made up of 1 sodium and 1 chlorine. And so we have 1 mole of sodium atoms is 22.99 grams. And so where do you get that from? Well, if you have a periodic table close by, all you have to do is look at sodium here up above. Sodium up above. There, the very bottom number is your atomic mass, which we just learned as well. It can also be the molar mass, and so 22.990. And so we take that mass, okay, in grams, and then we do the same thing for chlorine as well, which is 35.45. We add those two together, and we get 58.44 grams of sodium chloride per mole. So that's just the first step. Okay, so the next step after you figure that out is we have to calculate the percent of each of those elements. And so sodium here. So now we have the mass of just one mole of sodium is 22.99 grams. You have to divide that by 1 mole of sodium chloride, which is 58.44. Once you do that, multiply it by 100, you get 39.34%. Repeat the same thing with chlorine. So 1 mole of chlorine atoms is 35.45. And then you divide that by 1 mole of sodium chloride, 58.44 grams, multiplied by 100, and you get 60.66%. So an easy way to check if you did it correct or not is to add up all your percentages. It should come up to close to 100%, if not exactly 100%. And so I think we should go through one more example here. And so we've got lithium carbonate. And so let's do this one together here. First, we need to calculate the molar mass of the compound in order to calculate the percent composition of each of those elements. And so we make a list. We've got lithium, we've got carbon, and we've got oxygen. Okay, we need to take into account how many atoms we have of each of those. And so lithium, there are 2. Carbon, there is 1, and then oxygen, there is 3. Then we multiply it by its respective molar mass. And so lithium's molar mass, you find on the periodic table, is 6.941. Carbon's is 12.011, and oxygen's is 15.999. Pull out your calculator, do a little bit of math there. 2 times 6.941, we get 13.882. Carbon, of course, there's just 1, so still 12.011, and then 3 oxygens gives us 47.997, and of course those are all in grams. Once we do that, we can add them all up together to get the molar mass. So 73.89 grams. Okay, that's just the first step there. Now we need to calculate the percentage for each of those. And so we'll make a little list over here. We've got lithium, we've got carbon, and then we've got our oxygen. So you take the mass of each individual, so the total mass, the molar mass of lithium in that compound, so 13.882 grams, and divide it by its total molar mass. So 73.89 grams, okay, and you get 0.187 0.79, multiply that by 100, and we get 18.79%. So that's telling us that 18.79% of the mass of this compound here is made up of lithium. And so that's our first answer there. So 18.79%. Now we just have to repeat it for each of the other elements. And so carbon, 12.011 divided by the 73.89, and we get 0.1626, and we multiply that by 100, and that gives us the 16.26%. And so 16.2% of that total 73.89 is made up of carbon. And finally, the oxygen, which you can see makes up the majority there, 47.997 divided by the 73.89, and we get 0.6496. Multiply that by 100, and we get 64.96%. So there you go. So if you add up all of those, it should be roughly 100%, telling us that's 100% of that compound, and we did it correctly. And that is how you calculate percent composition of a compound. And I do want to show you one more thing here. There's a little bit more we can do with that. So if we're looking at, say, this compound here, potassium oxalate, we can determine, if you have a specific mass, say 125 grams in this case, how much of that is one specific element. And so it's here, how many grams of carbon can be recovered from 125 grams of potassium oxalate. And so start out the same way. So make a little list there, potassium, carbon, and oxygen. Okay, how many do we have of each? Well, we have 2 potassium there, we have 2 carbons, and then 4 oxygens. Now we just have to look up each one on the periodic table, finding the molar mass. And so potassium has a molar mass of 39.098, carbon 12.011, and then oxygen 15.999. So again, pull out your calculator, do a little bit of math. So the total mass of potassium is 78.196. Carbon's 24.022, and then oxygen would be 63.996. Add all of those together, and the molar mass of 1 mole of potassium oxalate would be 166.214 grams. Okay, the good thing is you don't have to go through and find the percentage of each one. If we only want to know what portion of that 125 grams of that substance is carbon, then we only need to calculate carbon here. And so if we just take the 24.022 grams, divide it by the 166.214 grams, then we get 0.1445. And then also, you don't need to times it by 100 to get the percent here. We want the decimal form. That makes it easier to multiply it by 125 grams. So 0.1445 times by 125 grams gives us 18.06 grams. So that means that of the 125 grams, 18.06 grams of that is carbon. And so it can be useful information if you're working in the lab. You want to know how much carbon is necessary, or you're going to get out of it if it is a decomposition. And so rewatch this video if you are practicing and forget what to do. Otherwise, work on practicing this so you remember how to calculate percent composition.